So, we're meant to have an agenda. I mean, yeah, we don't mind talking about papers, less about companies. This is for copyright issues. Happy to talk about papers. If you have anything specific in mind. Yeah, GPT always hallucinating papers, or at least used to. I'm pretty sure they're gonna solve this shortly. Do you study researchers, code frameworks? Code frameworks, we're using Flask web applications. it's giving me it's giving me papers from the website. Exploring biomedical data. Yeah, those links. Okay, that's a bit odd. Yeah, don't ask GPT anything specific, but what else? Frameworks to be able to stay updated. Frameworks. Well, LinkedIn. I don't know. Yeah, LinkedIn's pretty bad these days. Okay, so there's no specific. Yeah, specific questions are great. Even more specifically about the website at hand. So that's the website. Pop it in the link in the chat. If you checked it, do let me know. Provide your feedback. That's what we are doing this for. I'm about to just started. I'm about to lose my voice already, so we might use the robot to actually do the talking. And let's quickly. So we have a bunch of new tools on the site. What's interesting? What's interesting? Let's go through some of them because eventually, yeah, those will need an image. This one might not have an image. Yeah, it's just a blog. You can go read it yourself. There's nothing visual in it. We also have, yes, so this one has a code. So it's Python code that you can run, and it will generate an image like this for you. It's not an image. It's actually could be an interactive tool, and you could switch. Not could be. It is an interactive tool, and you could switch between 1020 EEG recording to 1010. Yeah, the buttons are confusing because, yeah, so this one showing 1010 and asking if you want to switch to 1020, and this one showing 1020 EG recording montage, and you can switch to 1010, and then you'll see this, and that's the code for it. So pretty straightforward. Yes, ideally this will be a Flask application, but currently just the Python code. Unfortunately, or fortunately, well, this makes the page a bit simpler. So let me know if there is any questions, suggestions about this one. We might move on. A fuzzy logic, right? So this one, there was one thing I wanted to do with it. So this is simulating. Yeah, there's something funny about those tip. What's it called? Tip something. Tips. Whatever information overlay thingy when you hover with your mouse. This is quite an extensive tool. There's an explanation at bottom. So trying to do fuzzy logic. This just that bit is the output of fuzzy logic. I don't know why so many numbers after the decimal point. We don't need it. Should fix that. Sure if I should do it straight away or later. Hey, let me know if it's very bothering you or just a little bit. The button doesn't work. Well, we don't actually need it because instead of generating signal, it just gets generated when you use the scroll. So when you load the page, those are the default values. You probably should have an option of increasing this window. Oh, hyper adaptive neural substrates. Okay, I don't know what it is. We can ask ChatGPT if you have if you don't have access to GPT-4 or something. Actually, I sometimes find the legacy model to give some better results. The 4.0 mini is not available because we were browsing to begin with. Encrypt the BCI plus VR glasses. That is already done. Okay, don't want to mention any country names. I mean, I'm happy to look anything up. You could get a raw comment. Well, now I'm actually curious. What is it? The hyper adaptive neural substrates. No, don't visit it. Hopefully, well, considering I don't know about anything about the topic, it's actually, yeah, so it's actually in a web searching mode. So it's meant to be better. Yeah, it's found MIT Press. Would this link even work? Neural basis hyper adaptivity in humans and animals. Yeah, the links might be broken or something. So normally, yeah, by the sound of it, let's read this out loud. I'm losing my voice.
The concept of hyper-adaptive neural substrates refers to the brain's remarkable ability to reorganize and adapt its neural networks in response to significant changes or damage. This ability is critical for managing impairments in sensory, motor, and cognitive functions. Hyperadaptability involves the reactivation and recruitment of latent neural networks to compensate for lost functions, essentially allowing the brain to rewire itself and maintain optimal performance despite challenges. One of the key studies on this topic is Learning Cognitive Flexibility, Neural Substrates of Adapting Switch Readiness to Time-Varying Demands, which examines how the brain adjusts its readiness to switch tasks based on changing demands. The study found that activity in the lateral and medial frontoparietal cortex is crucial for this cognitive flexibility, adapting to the likelihood of task switches by tracking prediction errors and adjusting neural responses accordingly. 33 source. Another relevant research topic is the neural basis of hyperadaptability in humans and animals, which explores how the central nervous system manages impairments by reactivating pre-existing neural pathways and creating new computational principles. This research highlights the brain's ability to restructure sensory motor maps and action selection rules, crucial for recovery and adaptation after severe damage. 34th source. For further reading, you can explore these studies and more on the MIT Journal of Cognitive Neuroscience, direct.mit.edu's JO/article/36/2377/ Learning Cognitive Flexibility Neural Substrates, and Frontiers in Systems Neuroscience.
Don'tiersign.org/research-topics/10103.
Okay,
now it's going places. Yeah, it sounds like it's just referring to neural plasticity. I don't know what the difference is. Hey, can you explain the difference between the two in one continuous text paragraph? Make it fun.
Imagine your brain as the ultimate superhero. Neuroplasticity is like its everyday superpower, allowing it to gradually get strong.
Okay, maybe reduce on the fun. What? Something went wrong. Regenerate. Yeah, working again.
Neuroplasticity and hyperadaptive neural substrates both refer to the brain's capacity to adapt and reorganize itself, but they differ in scope and speed.
Scope and
Neuroplasticity
speed.
is the brain's general ability to form new connections and reorganize existing ones over time in response to learning, experience, and minor injuries, encompassing processes like synaptic changes and neurogenesis. On the other hand, hyperadaptive neural substrates refer to the brain's exceptional ability to rapidly reconfigure its neural networks in
Sounds
response
the
to
same.
severe or sudden changes, such as significant neural damage or sensory loss. This involves not only forming new neural pathways, but also reactivating dormant ones to quickly restore function. While plasticity is a gradual, ongoing process essential for everyday learning and recovery, hyperadaptability is a swift and extensive reorganization mechanism that kicks in under extreme conditions to maintain neural and functional integrity. 33 source, 34 source.
Yeah, so the Frontiers link is broken. And the MIT Press one, well, yeah, we are not, might have too much details kind of thing. When was it published? Just recently. That's promising. The images don't look great. Switch probability. Behavioral. We are interested in behavioral accuracy. So okay, apparently there's a difference in the sense of, so it's essentially the same thing, but supposedly hyper. That's weird. Cognitive flexibility, neural substrates of adapting switch readiness to time varying demands. It's like a classic mouthful of a title. Not sure if we can get anything out of it. A main thing we essentially don't read any papers that has no data availability. So in this case, all behavioral data code for running the analysis and stimulus presentation code are available at yeah, OSF is good. I forget what it stands for. But yeah, we used this one before. Really should spell out what it stands for. Problem is, Yeah, with this particular datasets, that all raw MRI data are available upon request. I was like, okay, this is code name for it's not available. Well, because there's no point having part of the dataset if I don't have access to all of it. I cannot replicate the results. So I don't understand what's the point of making only some of the data available. The code is in okay, so they use MATLAB. We don't use MATLAB because of its cost, not because it's not good. Yeah, I mean, we can convert the files, but again, I don't see a point because not all the data is there. The MRI data is missing from the dataset. So that's that paper. Yeah, so plasticity, it's a gradual change in response to normal developmental processes, learning, and minor injuries. And hyperadaptive substrates involves rapid, extensive reorganization in response to severe injuries or significant functional impairment. Okay. Plasticity relies on synaptic changes, and the hyperadaptive substrates involved reactivating dormant pathways and forming new neural frameworks quickly. I don't know what's the evidence for the difference between them. Like it's essentially the speed difference. So plasticity happening when you're learning new skills, and hyperadaptive substrates is rapid adaptation following spinal cord injury or severe brain damage. So is hyper adaptive substrates is a special case of neuroplasticity. Can't be bothered correcting spelling. I don't think it adds much.
Yes, hyperadaptive neural substrates can be considered a special case of neuroplasticity. Neuroplasticity broadly refers to the brain's ability to reorganize itself by forming new neural connections and adjusting existing ones in response to learning, experience, and recovery from injury. This encompasses various processes like synaptic plasticity, structural changes, and functional reassignments. Hyperadaptive neural substrates, however, specifically describe the brain's capacity to rapidly and extensively reconfigure its neural networks in response to extreme or sudden changes, such as severe neural damage or loss of function. This involves quickly activating dormant pathways and creating new neural frameworks to maintain functionality under challenging conditions. Essentially, hyperadaptability represents an intensified, rapid, and more comprehensive form of plasticity that is activated in response to more severe disruptions, highlighting the brain's remarkable resilience and capacity for rapid adaptation. 33 source, 34 source.
It seems to stuck now on these two papers. Can you provide more resources except this one? Also, we would like eventually to turn this into a Flask web application. We already have a bunch running on the website, as you know. So just don't start coding. Just continuous paragraph text would be awesome. Pretty sure it's the same. It's stuck. Yeah, it's really bad on finding links. So it knows that there is something. Yeah, we are interested in stroke recovery. So neuroplasticity after stroke, to know. We're always on the lookout for good data sets.
To further explore the concepts of hyperadaptive neural substrates and neuroplasticity, you can delve into several academic articles and research studies that examine these phenomena in detail. A comprehensive understanding can be drawn from sources like the article Learning Cognitive Flexibility, Neural Substrates of Adapting Switch Readiness to Time-Varying Demands, which discusses the brain's ability to adjust task switching readiness based on changing demands, and highlights the role of the frontoparietal cortex in tracking and adapting to prediction errors. 33 source. Another valuable resource is the collection of papers on the neural basis of hyperadaptability in humans and animals, which explores how the central nervous system reactivates and recruits latent neural pathways to manage sensory, motor, and cognitive impairments, emphasizing rapid reorganization and computational restructuring. 34 source. Additionally, studies on neuroplasticity, such as Principles of Neuroscience by Kandel et al., provide foundational knowledge on how the brain's synaptic connections and neural structures change in response to learning and experience. The review, Neuroplasticity and Its Functional Implications, in the Annual Review of Psychology, offers insights into various forms of plasticity, including synaptic, structural, and functional changes, and their implications for behavior and recovery from injury. For practical applications and examples, the National Institute of Neurological Disorders and Stroke, NINDS, provides resources and information on neuroplasticity related to stroke recovery, while the journal Frontiers in Human Neuroscience frequently publishes articles on adaptive changes in the brain due to different experiences and injuries. To bring this knowledge into a more accessible format, you can develop a Flask web application that presents interactive visualizations and simulations of neuroplasticity and hyperadaptive neural substrates. This could include dynamic models showing how the brain reorganizes after injury, educational tools explaining the mechanisms of neuroplasticity, and case studies highlighting remarkable instances of hyperadaptability. By leveraging your existing expertise in Flask applications and incorporating these advanced concepts, you can create a valuable educational resource for researchers, students, and the general public interested in the fascinating capabilities of the human brain.
Yeah, there's a lot of data sets. We have a whole list somewhere on the page. It should be on the front as well. Yeah, e.g. datasets and resources. So we're actually looking at a bunch of those. That's the main one that I was looking at. And it's now moved to another platform as well. Yeah, so you can be chasing datasets forever because they also keep moving around. Yeah, I think it's actually moved to this PanCF Discover repository. So that should be a new repo. Yes, 650 gigabytes scalp and the intracranial. It's a high res. Updated last year. The dataset must be a fairly old. Banner image, okay. Okay, lay file. Yeah, this actually looks promising. There is something in MATLAB, but we don't have to use it. The actual data is in lay data files. Does the website have no viewer available for? Okay. I don't even know if I have a viewer for. Let's check to. Can we actually download? Yes, so download works without with no logging in or anything, which is something we are always looking for. Yeah, don't want to show it because it might be copyrighted. What's the... Okay, it's Creative Commons Attribution License, non-commercial use. Well, we're not commercial, I guess. And we are running ads on the website, so that could be considered commercial use. Maybe, maybe not. Yeah, just a messy slideshow. Yes, showing the brain, all the locations. Yeah, some gory images of where the electrode was placed. Yeah, some typical seizures. Nothing special. So how did they record so much data? Yeah, it must be high frequency rate, high sampling rate. Because how many electrodes? 7 days of scalp EEG and 8 days of intracranial EEG, 5 electrode grids, and 1 electrode strip. Okay. Yeah, it's a very specific case. Yeah, we have worked with these lay files should contain. There's no viewer for this one. Yeah, even the IEG.org had a viewer. Oh, come on. Yeah, those are persist files. You can load one of those, I guess. The lay file should be just text. Why are we having trouble opening it? Can open it in Python, I guess, and should take like 5 minutes or something. Let's see. Okay, lay files are interesting. Let's actually, yeah. So okay, maybe we are getting somewhere. This is an interesting data set. We need the corresponding binary. So the actual data. Oh, come on, it's always going back to the main page. So we have the lay data day 1, 19 day 1. Yes, 72 gigabytes. Let's see. Save link as. No, that's saving HTML. We don't need HTML. We need the actual .dat file. It's a binary. Let's see how fast. What error? There was an error creating the zip. Please check the logs. So it's meant to be zipped before downloading. Um, okay. Can download from AWS. Can we just use on Ubuntu? We would like to download the dataset from AWS. How to do it through the command line? The link is as following. Let's see if it can do it. Blah blah blah. AWS. Recursive. And let's try this one quickly. I have a lot of storage. Storage is not a problem. Problem is Yeah, how to actually. Don't think this will. Okay, don't trust it. Do I trust it? Install. We don't have credentials. Okay, so it sounds. Request a pays, so I need to pay for something. Need to pay for something. So is it available or not? Don't think we'll be paying for it. Can I just get the one file? Which one's smaller? 72, 64, day 5. This is another session or something, is it? Yeah, we need the data for that whole session. So that's the subject ID. I guess it's session 03, day. No, that must be the subject. Wait, how many subjects? Check the slides. Slides just disappeared. Anyway, I need one of those data files. Say day 5. Ba-bow. So you do need a login or something. Do I have login? No, I don't really want to log in. Yeah. Good luck with that. If the dataset is smaller than 5 gigabyte, you can download it off the browser, I guess. All data's can be accessed directly, interactive, blah, 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 blah. Create the account for getting that. Yeah. Yeah, we might try it another time because this essentially requires creating and configuring the AWS account. Yeah, we installed the command line interface. Not a great website, is it? uh, you, can you download only some of the data? Metadata. Well, that's obviously too small. It's only the kilobytes. Yeah, we have some EEG data, which is pretty good anyway, so can always look at that one. Yeah, it becomes a bit of a data engineering kind of task, converting file formats from one to another. Yeah, that's the one actually we are using. Yeah, it used to be on a different repository, on a different domain. Yeah, it used to be more subjects as well in it. Some meth. What's a meth file? No, this one actually downloading. So it's downloading anything, I guess, below 10 gigabytes or something. So you can download off the site. It's just our files are too large for this. Well, it's downloading something. A meth file. This will be only one. Oh, come on. It's always going back to. Yeah, it has 16 channels. So this will be only one channel. So yeah, so that's around 10 gigabyte per channel. But that will be many days worth of recording. And these dogs had naturally occurring seizures. So we're already looking at this dataset. You can scroll through it, well, sample of it using a bunch of these tools. So the spectrogram, the EEG noise removal will have the same dataset used. The Human Connectome project. Why should I not use the data from it? Can a data sample be freely downloaded from the web without registration or login? Can you browse for a link? Probably shouldn't be downloading while streaming. I'll pause the download for a sec. And also, it's only one of the channels for one of the subjects. But yes, it will be a very long term. It's yeah, it's roughly like 300 days or so. So it's an implant. Did I lose any frames? No, didn't drop any frames. Give me a link. There's a data agreement. So that's the problem. Maybe I was looking at it before, and that's the reason I didn't want to actually use it. It's again on AWS, which yeah, it's okay, but we don't particularly like. Yeah, we should add the human connectome project to the mix, but I think there might be a reason why it's not there to begin with. I think it's also a general, isn't it a general name for many different data sets? There is the CHP MIT scalp, so that one pretty sure is accessible. Oh, I can swear I checked all these links. That link, now that link is an ad. Yeah, that's placed by Google. Uh, I think I had a video about this one. It just went, just disappeared into thin air. This one on Zenodo. It's a small one. Yeah, I mean, it was suspiciously small. The like 100 megabytes. It's a red. Does it say red? Yeah, 31 reds or something. Yeah, we don't really want to do reds. Yeah, I was looking at this one. Somatosensory evoke potential of fingers, limitation, clinical potential, raw data. In searching for predictors for recovery of upper limb function post-stroke, we studied the reproducibility of somatosensory potentials evoked by finger stimulation in healthy subjects. The modality that we used, yeah, was, so it is EEG. It's human subjects. Let's actually go back to the page, resources. Let's open it up for a sec. Resources. Yeah, we have those. Pretty sure I used those links in the actual HTML. Let's put it in the, yeah, might need updating this. I'm pretty sure this data set was on this link. Well, there's a lot of on a PhysioNet. What's an RSVP? Rapid serial visual presentation. Healthy participants. Like the open access ones. Yeah, so PhysioNet should be good. But the table will be pain to edit. How do we edit that table? Yes, that one not available. Control I, add the text to the link. No, longer. No, wait, that should not be in the link, should it? It's the accessibility thing. Data format, number of subjects, description, accessibility score. Yeah, so that's accessibility score. Yes, no longer available at the current address. Maybe it's available somewhere else. So the this IEG only has the intracranial. Still working? Yeah, this one does require login, but I'm pretty sure anyone can log in and use it. There's a lot of data sets there, but so this is University UPenn, and this Penn Severe, this thing is now a replacement for the IEG.org. But yeah, so those traditionally were only invasive datasets. This one has a big login button, but will this? This just downloading, so supposedly, yeah, we need some sort of download ranking on the page. So this will be the 40U. 40U. Supposedly raw data. We haven't actually looked at this one. one's from 2021, 2020, 2018, 17, 2010. Wait a sec. There it is. Isn't? Yeah, they must have just broken it down to different data sets or something. It's then no longer available. Yeah, this CHB MIT. Yeah, it's probably one of those like connectome projects which had like many patients, and it's probably just being broken down to pediatric subjects with intractable seizures. Well, yeah, that's the one. Why the link didn't work then? Yeah, you have the data there. I'm pretty sure you can download it straight away. There's no registration. Yes, it's subject. Yeah, EDF files are good. They're broken down, so you can download only some of them if you like. Yeah, it's actually downloading the EDF. Yeah, we could do a tool on opening an EDF file. Let's actually finish downloading this one. Yeah, it's pediatric. Why the link that I had was not functioning? I just changed the link or something. Wait, it's the same files panel. Wait, what's the link? Just had this one, isn't it? Ooh, I didn't have the content in there. So just stuffed up the link because yeah, so it should be that. Yep, stuffed up the link. No, it's working fine. It's pretty old though, 2010. Let's see, it is available. It's open access and all. Fix the link. So IEG.org works. This is an auto a quantification of stroke lesion volume using epidural EEG. Yeah, so that we use that one a lot. I'm pretty sure the site wasn't updated for forever, for quite some time. So yeah, you can see they have GitHub repo. You can see when was the last time it was updated. It would be a while back. This one just requires simple, like anyone can register and you can fetch the data yourself. And that's the data we are using on some applications on the website. Hey, can you explain all this? Just go over it in text. Do not generate any new code or don't include any code in your response. But just give a text summary of what's on this page. Is there a summary? There is a summary. Could probably improve it. Blah blah. Okay. Okay, can you actually go into the details of the text? Yeah, probably have to break it down into multiple pages.
Certainly. Here's a detailed overview of the text content in the HTML page you provided. Metadata, description and keywords. The page is designed to provide comprehensive information on EEG datasets, research publications, software tools, hardware devices, and APIs. Keywords include EEG, electroencephalography, brainwave analysis, and related terms. Open Graph metadata. The metadata includes the page title, description, image, and URL to improve social media sharing. Authored by Bionichaos. Published on May 1st, 2024. Header and navigation. Logo and navigation menu. The header includes a logo and a navigation menu with links to the home.
Yeah, don't worry about the logo and the navigation menu. Just cover the text. Don't mind it going into details. We would eventually like to improve this page that we have on the site. But at this stage, don't generate any code. Don't include any code. And if possible, use continuous sentences and whole paragraphs.
The page EEG Datasets and Resources is designed to offer a comprehensive overview of various resources related to EEG, electroencephalography research. Here's a detailed description of the content presented. #Welcome section. The page begins with a welcoming message, introducing visitors to a vast collection of EEG-related resources. It highlights the primary goal of providing extensive information on EEG datasets, research publications, software tools, hardware devices, and APIs. The message is aimed at researchers, students, and anyone curious about EEG, emphasizing that the curated selection of resources offers valuable insights and data for exploring the field of brainwave analysis. E-dataset platforms. This section lists several platforms where EEG datasets can be accessed. Figshare, a general-purpose repository for research data. 4TU.research data, a repository for technical sciences data. Zenodo, an open-access repository for research data developed by CERN. Physionet, a resource center for complex physiological signals. IEEG Portal, a platform specifically for intracranial EEG data. Penziv Discover, a data discovery platform. Kaggle Datasets, a repository for datasets used in machine learning competitions. Google Dataset Search, a specialized search engine for datasets. Dataset Comparison Table. The page features a detailed comparison table that evaluates various EEG datasets across multiple attributes, including dataset name, the title of the dataset, description, a brief explanation of what the dataset entails, Number of subjects, the number of participants in the dataset. Data format, the format in which the data is stored, e.g. EDF CNT. Year of release, the year the dataset was made available. Data type, the specific focus of the dataset, e.g. stroke-related epilepsy. Quality, an assessment of the dataset's quality. Accessibility score, how easily the dataset can be accessed. Data processing, information on the data processing involved. Additional modalities, any other types of data included. Link, a direct link to access the dataset. Specific EEG datasets. This section categorizes datasets by their research focus. Stroke EEG datasets lists datasets related to stroke research, such as EEG recordings from stroke patients and datasets for quantifying stroke lesion volumes. Epilepsy EEG datasets includes datasets focused on epilepsy research, such as the NeuroVista implant data, the CHB MIT Scalp EEG database, and the Kaggle seizure prediction data. Have general health data. A link to the 2019 Global Burden of Disease (GBD) study is provided, offering a broader context for health-related data. Publications. The page lists various EEG-related research publications, marked with accessibility indicators where applicable. EEG research covers topics like data integration, epilepsy, and specific methods for analyzing EEG data. Fuzzy logic includes publications on applications of fuzzy logic and neural networks to EEG data and fault diagnosis. Stroke EEG papers focuses on EEG features during stroke recovery. Sleep EEG papers discusses detecting sleep spindles and classifying sleep stages using EEG data. EEG software. A list of software tools is provided, with open source options marked clearly. These tools support various aspects of EEG data analysis and visualization. EDF browser, a tool for viewing and analyzing EDF files. EEGLab, a MATLAB toolbox for EEG, MEG, and other electrophysiological data. M&E, a Python package for EEG and MEG data analysis. Field Trip Toolbox, a MATLAB toolbox for analyzing MEG, EEG, and IEG data. OpenVibe, software for designing and using brain-computer interfaces. ERPLab, a MATLAB toolbox for ERP data analysis. Devices. This section lists hardware items useful for EEG research, indicating those that provide data access. NI-USB 6215, a multifunction I/O device. Siesta Wireless EEG Amplifier, a wireless EEG recording device. Nicolet electrodes, electrodes and caps for EEG recording. Biosimi amplifiers, EEG amplifiers from Biosimi. EEG SDKs and APIs. A list of software development kits and application programming interfaces for EEG data. OpenVibe, an open-source software platform for brain-computer interface research. BrainFlow, a toolkit for processing EEG data. BCI 2000 Web API, an API for accessing brain-computer interface data. EEG API by NeuroSky, an API provided by NeuroSky for EEG datadogs. A link to NeurotechX, a blog focused on neurotechnology and EEG research. Overall, the page serves as a centralized resource for EEG research, offering links to datasets, tools, publications, and more to aid researchers and enthusiasts in their studies.
How should we improve the table on the page? Particular problem is that the description is too long, so the table becomes hyper long. Also, we would like to be able to edit it in a better way rather than just adding the HTML on the page.
To improve the table on your page, here are a few suggestions. 1. Condense descriptions. Use tooltips or modals. Instead of showing the full description in the table, use a short summary or keywords. Add a tooltip, a small box that appears when the user hovers over the text, or a modal window, a pop-up box that appears when the user clicks on the text to show the full description. 2. Use expandable rows. Expandable rows allow users to click on a row to expand it and see more details. This way, the table remains compact and only expands when the user is interested in a specific dataset. 3. Split the table into multiple pages. Pagination. Implement pagination to split the table into multiple pages. This reduces the overall length of the table on a single page and makes it easier to navigate. 4. Editable data table plugin. Data table plugins. Use a JavaScript library like data tables, which offers features such as sorting, searching, pagination, and inline editing. This will make the table more dynamic and user-friendly. Implementation in HTML, example. Instead of editing the HTML directly on the page, you can use JavaScript to dynamically manage the table. Here's how you
Okay, we also need to be able to edit the table in a more straightforward way. This is what we currently have for the HTML. Any suggestions are welcome. Yeah, this session is meant to be interactive, so if you have any more questions and comments, complaints, do let me know. Currently, we're actually prompted to work on the resources page. And this one here. So this will be hopefully updated shortly and be made better. Yeah, the bot is giving some great suggestions, turning the data into a JSON file. That sounds very helpful. Can it actually generate the whole JSON file from what we currently have? It's generating the HTML. Probably won't do the JSON file because it's already did it with what's called the placeholder, which we don't like placeholders. Okay, we still have this HTML. Could you move the data for the table into a JSON script? Yeah, the table looks better, but can we improve it and make it fit a single window screen better? Let's see if it suggests JavaScript. Not much better. We're probably thinking going back to the previous version. I don't think there's need to not show the whole text for the dataset name and the number of subjects and other columns, except the description. That I think that's what's causing a visualization problem, because it's too long. So, any suggestions? This is better in terms of the description, but the read more functionality is really good. but the dataset name column is too wide. We should half it and also make the text wrap into multiple lines if needed. Forgot the name for this.
To further improve the table's appearance by narrowing the dataset name column and allowing the text to wrap within it, we can apply some additional CSS. This will make the table more compact and improve readability. Here's the updated HTML. HTML, doctype.
Yeah, the search functionality is great. The description column is really nice to have the read more button, but the column itself can be made a bit wider. Now, all the other columns, can we make sure that the text actually wraps? So in the dataset name, for example, the whole name should be visible because it will be going into multiple lines. So as many lines as needed. Oops, forgot. Ah, no, I did include the image as well. Okay, this is really nice. Okay, this is really nice. Just one concern is what happens like in this case where the entire table doesn't fit in the width of the page. Can we address that in a better way? Also, what's up if the rows will be populated dynamically using JavaScript thing? I don't currently have JavaScript. Do I? Don't know if I see a script. Yeah, we making the table scrollable horizontally. It's an improved version, so it does not require any more JavaScript, does it? Okay, wait a second. So we're having the data set in a separate JSON file. That's actually good. I would like to keep it that way. So it's actually easier to edit in the future. Wasn't that the idea? The file and folder structure looks okay, but do I need a static folder? So it's actually being cached by the CDN. Okay, bear with me. This will require some modifications. Also have to remember that in the original page we had way more details. So we'll essentially be breaking them down. Or not. I don't know yet. We'll see in a sec. We don't need the table. Yeah, it's like 150 lines. Actually have a separate page for EG hardware. Somewhere. Yeah, we'll split the hardware in a separate. Do have a separate page. It's not actually covering specific hardware. Yeah, this will need updating as well. You're making this resource page better, stronger. Actually need an info. Yeah, we have the info page. Need a static folder. Okay, the dataset JSON goes into static. Then we have a CSS. Style CSS in it. JavaScript folder in the static. Have the script.js. The other file will be coming from just need to download it. Yeah, we have the jQuery. How do I? Do I just copy the text? Three, 6, 0. There's a 3, 7, 1. It could be that GPT doesn't have examples of this thing. So we need the minify, do we?
The recent changes involved restructuring the project to improve the organization, maintainability, and performance of the EEG dataset webpage. The primary goal was to move the dataset information into a separate JSON file, making it easier to edit and update without modifying the HTML directly. This approach allows for cleaner code and separates the data from the presentation layer. To achieve this, the HTML file was updated to include references to external CSS and JavaScript libraries stored in a static folder. This folder contains all static assets such as CSS, JavaScript, and the JSON data file. The folder structure ensures that these assets can be efficiently cached by CDNs, enhancing page load times and overall performance. In the HTML file, the data tables library was used to create a dynamic and interactive table. Data tables provide features such as pagination, searching, and sorting, which improve the user experience when navigating through large data sets. The table's appearance was enhanced with custom CSS to ensure proper text wrapping and a responsive design that works well on various screen sizes. A JavaScript script was added to fetch the dataset information from the JSON file and populate the table dynamically. This script uses jQuery to handle the data fetching and the data tables API to manage the table content. An additional feature was implemented to handle long descriptions within the table cells, truncating the text and providing a read more link to expand the full description on demand. This restructuring and the use of external libraries not only make the project easier to maintain, but also significantly improve the user interface and experience. The separation of data and presentation allows for straightforward updates to the dataset, while the use of caching and efficient data handling ensures fast and responsive performance for users accessing the web page.
Why do we need a separate... why do we need a separate libs folder? Considering we only have JavaScript and CSS files in it.
Having a separate lib/folder for JavaScript and CSS libraries is a common practice in web development for several reasons. 1. Organization. It helps to keep third-party libraries separate from your custom scripts and styles. This distinction makes it easier to manage and update these libraries without confusing them with your own code. If you only have a few files now, it may not seem necessary, but as your project grows and you add more libraries, the separation will prove useful. 2. Maintainability. When libraries are stored in a dedicated folder, it's straightforward to update or replace them without affecting the custom code. If a new version of a library is released, you can simply replace the files in the lib/folder. 3. Clarity. It clearly distinguishes between third.
Okay, why is this one in the other folder, the JavaScript folder, and not the libs folder? You might have to open it in a separate window or not. Maybe not. Okay, we have the HTML updated. We have another libs folder. We're moving that one. Okay, let's find the original. Okay, we have that CSS. But wait, it's something else. Do we really need this one? They look redundant. Looks the same. Why do we have so many? Should have only 3 of them. Yeah, we don't need that, I think. This one's having errors in it. What?
The error message you're encountering, data tables warning, requested unknown parameter 0 for row 7, column 0, suggests that the data table's library is not correctly identifying or receiving the data it expects to populate the table. This often happens when the structure of the data or the way it's being passed to data tables doesn't match the table configuration. Here are a few steps to troubleshoot and resolve the issue. Steps to troubleshoot. 1. Ensure data structure consistency. Make sure that the JSON file datasets.json contains the correct structure and all necessary fields. 2. Check data loading. Verify that the data is being correctly fetched and passed to the data table. 3. Ensure table column matching. Confirm that the number of columns in the table matches the number of data fields in each JSON object. Overview of the updated approach. The code provided aims to improve the maintainability of the project by moving the dataset information into a separate JSON file, ensuring that data updates can be made without modifying the HTML file. This setup allows the use of the data tables library to create a dynamic and interactive table that supports features like pagination, searching, and sorting. Key components. 1. HTML structure. The HTML file includes references to external CSS and JavaScript libraries for styling and functionality. 2. JavaScript for data fetching. A custom script fetches the dataset information from the JSON file and populates the table dynamically. 3. CSS for styling. Custom styles ensure that the table looks good and is responsive across different devices. 4. Folder organization. The project structure separates static assets into a static folder for better organization and potential CDN caching. Adjustments in the HTML and JavaScript. HTML. Ensure the table in index.html is set up correctly. HTML, doc.html, head, meta charset, UDF port. Content, width, device width, initial scale. Title, EEG datasets and resources. Link rel style sheet type text CSS, refi static libs, slash jQuery.data tables. Link file static cs / dot terik jQuery -3.7.1.7 the static libs static JS script died. Body div class tablecon1 id EEG dataset table class display name description number of subjects data format year of release data type quality accessibility score data processing additional modalities link body. Data will be populated dynamically from JSON. JavaScript. Ensure the script.js fetches data correctly and matches the columns. JavaScript document ready function. .getJSON static datasets JSON function data. var table equals hashed EEG dataset table. Data table .each t dataset. var description equals dataset.description.length 100. Dataset.description.substring 0 100. Span classics read more data full text equals dataset.description. Dataset.description. Table.row.add, dataset name, description, dataset.number of subjects, dataset.data format, dataset.year of release, dataset data type, dataset.quality, dataset.accessibility score, dataset data processing, dataset.additional modalities, aref equals dataset.link targeted blank draw false. $shash EEG dataset table tbody dot on click span.read more function var full text data full text. This parent.html full text summary. The current setup ensures that the dataset is fetched from a JSON file and dynamically populates a data table in the HTML. The table has been configured to handle long descriptions with a read more functionality and is styled to be responsive and visually appealing. Any issues with table population likely stem from mismatches in data structure or incorrect column definitions, which can be resolved by verifying that the data fields and table columns align correctly.
I did download the external files locally, and this is the current file and folder structure that I have. Why is the text after read more is being shown instead of being hidden? Let's keep messing messing the folders around. Okay, for simplicity's sake, we are using the CDN at the moment for external library files. Also, can you generate the whole CSS file? Okay, it looks good, I think. You know what you think? The search seemed to work okay. I'm not sure if it should. Yeah, so that horizontal scroll is within the table itself, whereas the vertical scroll is for the whole page, which is kind of not ideal. Let's try. Instead of the link being in a separate column, can we perhaps add it to below the dataset name text? Can you do it for me? It's adjusting too many things. Yeah, still using the CDN. That should be okay. Well, whatever works, kind of thing. Do I need to change the JSON file or leave it as is? It's always inclined to. So if you can leave it as is, why are you generating? It's just a recap. Okay, fine. So we have the JavaScript 33 lines, 28 lines. Okay, we'll check the links in a sec. This is looking good. Can we place the view dataset link in a new line? A different name, why? No, this is VisioNet. The read more button doesn't work. Okay, a couple of things. Can we make sure to have even less text in the description, shown in the description before clicking the read more button? So keep the text as it is, just show less unless the read more button is pressed. And also we need to actually make sure the read more button actually works. Wonder if we should do a table like this for the main, for our landing page. I'm pretty sure I got rid of some text. I think a simulation repeated twice. No, that's fine. We change the order. That should be okay as well. The HTML must be the same. I don't know why it's regenerating it. And this is opening in a new window. This is nice. The table looks great. However, it's a bit too long. Can we make sure it only fits within, say, 80% of the window height somehow? Okay, this is actually very nice. Thank you very much. Just check that the links are working. Yeah, I was wondering why we only have 4. Yeah, the other question is if scrolling through these things. Yeah, we'll probably make a table for the landing page as well. But actually, I'm thinking a similar table for my landing page. Question is, can it not look like a table? Can it actually look like a proper web page? Can you respond with text only? Continue sentences, no code. Avoid the code and the timestamps. And avoid the dot points.
To transform your table of EEG datasets into a more visually appealing and web-friendly format for your landing page, consider incorporating design elements that enhance user engagement and readability. Instead of a traditional table format, you can organize the data using sections, cards, or panels, which provide a cleaner and more modern look. Each dataset can be presented within a distinct card or panel, making it easier to digest and visually appealing. Start by structuring the landing page with a welcoming introduction, providing an overview of the EEG datasets and their significance. Use headers and subheaders to categorize the datasets by type or application, ensuring that users can easily navigate to the information they need. For each dataset, include a brief description, key details, and a link to view more information. This approach allows for a concise presentation, reducing the clutter that often accompanies tables. Utilize CSS for styling to ensure that the content is responsive and adjusts seamlessly to different screen sizes. By adding hover effects, shadow boxes, or slight animations, you can make the interactive elements more engaging. Furthermore, ensure that the Read More functionality for descriptions works smoothly, expanding and collapsing text dynamically without disrupting the overall layout. Additionally, consider incorporating icons or images related to EEG research to add visual interest and break up the text. These graphical elements can help illustrate the different types of datasets and their uses, making the content more relatable and easier to understand. Overall, focus on creating a user-friendly interface that prioritizes readability and ease of access. By structuring the information in a visually appealing way, you can enhance user engagement and provide a better experience for visitors to your landing page. To further develop the landing page, continue by integrating clear and intuitive navigation. Make sure that the layout includes a top navigation bar or a sidebar that allows users to quickly jump to different sections of the page, such as specific types of EEG datasets or related resources. This helps in maintaining a seamless user experience, especially for those who are looking for particular information. Each dataset card or panel should have a consistent design, which includes the dataset name, a concise description, the number of subjects, data format, year of release, data type, quality, accessibility score, data processing, additional modalities, and a link to view more details. Using a card layout ensures that the information is organized and easily scannable. The Read More links can expand descriptions within the same card to avoid navigation away from the page, maintaining user focus and context. For the design, consider a clean, minimalist approach with a focus on typography and whitespace. This enhances readability and prevents the page from appearing cluttered. Use a color scheme that aligns with your brand and maintains a professional look. High-quality images or icons relevant to EEG research can be strategically placed to add visual appeal without overwhelming the user with too much text. To make the page interactive, incorporate elements such as sortable and filterable lists, allowing users to sort datasets by criteria such as the number of subjects or year of release. Filters can help users narrow down datasets based on their specific needs, such as stroke-related data or epilepsy research. Lastly, ensure that the page is optimized for performance and accessibility. Fast loading times and compatibility with screen readers are crucial for a positive user experience. Use semantic HTML to enhance accessibility, making sure that all interactive elements are keyboard navigable and that the site is usable for individuals with disabilities. By implementing these design and functionality enhancements, your landing page will not only look more professional, but will also provide a better user experience, making it easier for visitors to find and interact with the EEG dataset information they need.
So this is what we currently have. It only has 9 entries, but the table looks great. Back to the table that we are making. Can you look at this link and update the data in JSON file? So if it did okay with the number of subjects. EDF, does it mention? Yes. That's great because currently don't have that information. Quality, okay. Why does it assume? Just curious. Yes, the number of subjects seem correct. The file format is correct. The year is correct. But how did you assume quality? And where did you get the fact that it's pre-processed? Okay, does not explicitly state high quality, but it's widely used in research, indicating it's well regarded. Open access. The temporary process was incorrectly assumed. Typically, raw EEG data from such dataset is not pre-processed unless stated otherwise. Okay. Quality. Widely used. Okay. Fetch JSON file. The link is working. How's the order being decided? It's based on dataset name. Okay, can you do the same for this link of another dataset? And also just make sure you also indicate what was changed from what we currently have in data. We will, of course, check everything. Let's read this quickly.
Sure, let's review the information from the provided link for the brain wearable monitoring dataset on PhysioNet and update the JSON accordingly. Information from PhysioNet for brain wearable monitoring dataset. Dataset name, brain wearable monitoring dataset. Description. This dataset contains data collected from a wearable brain monitoring system in a real-world environment, aimed at evaluating the feasibility and reliability of continuous, long-term EEG monitoring outside the laboratory. Number of subjects, 15. Data format, EDIR of release, 2020. Data type, continuous EEG monitoring. Quality, high, indicated by the dataset's detailed description and application in real-world settings. Accessibility, open access. Data processing, raw. Additional modalities, not specified. Link, brain wearable monitoring dataset on PhysioNet.
Did you actually check the number of participants in experiment 1 and experiment 2 as well? So it's actually doing it. It's actually fetching data correctly. Just didn't look at the whole thing.
For the dataset on PhysioNet titled Regulation of Brain Cognitive States through Auditory, Gustatory, and Olfactory Stimulation with Wearable Monitoring, it involves 2 experiments with a total of 28 participants, 15 in Experiment 1 and 13 in Experiment 2. The dataset includes.
Okay, can you update the table accordingly? Update the previous response. Hey, can you update the relevant section within the JSON file? Let's skip the meant to be 2023. Hey, can you double check the year? It's actually browsing or doesn't look like. No, it is browsing. Right. I did update to 2023. But what are you doing with the subjects? What? Can't comment out like this. Why? Should get pre-processed again from. Yeah, 28 is correct. The link is correct. Again, why did you assume? The year, I'm pretty sure it's 23. Why did you assume quality? Is the data pre-processed? Like how excluded data is actually included. That's nice. Yeah, there's no it's called the AWS. That's also nice. Well, I don't know where the data is actually stored, but you can download it off the website itself. Yeah, if we keep the original name, that would be good. Yeah, this dataset includes a lot of modalities. That's nice. There's actually more time between individual heartbeats, average heart rate, blood volume, pulses. Can you double check what modalities exactly were recorded? So we have EDA, yes. How about temperature? How about temperature? Why? Um, yeah, it's real weird. Are you sure about temperature? And I will say no. Sorry, made mistake. It does said does it record PPG? Doesn't mention PPG. What are you talking about? Yeah, you have to be really super careful with this. With the board. There would be PPG. It would mention. It actually does. Is the PPG data included? No, so the bot, sorry, the bot was correct. It doesn't look like there's PPG there. What device was used? A two Empatica and use a headband. Okay, that's interesting. And we don't have it in a table, do we? Yeah, we could really improve the table. And what devices were used in this particular study? Well, that seemed to be correct. 4 channels on the Muse. And yes, Empatica, we're actually quite familiar with it. We actually have one of those lying around somewhere. I have it in here. I haven't been running for a while. The problem with E4. Are there any issues with Empatica E4? Was it by any chance discontinued or something? I don't know if it has this information or not, but it's still being supported. That's good to know. Yeah, that's I believe this is to be correct, that I'm actually wrong and it was not discontinued, so you can still use it. It's just the one I have didn't work quite well. It's okay. In our table, we would like to improve the table. We would like to add information about what devices were used, but we don't want to make the table any bigger. Any suggestions are welcome. Yeah, the data format is not yeah, it's not very important, is it? Yeah, we can just have an one data column. Yeah, I would like to improve this table. We would like to improve the table by actually simplifying it. How about the following changes? So instead of a dataset column, can we just have dataset? That column should include the name, the year of the data, and the link. Then the description column can stay as it is. And then we remove the number of subjects. We just have a data column instead, which includes the number of subjects, the file formats, the data types, any details about the data processing. So essentially specifying if it's raw data or not. Instead of what additional modalities, we would like modalities column that includes all the modalities of the data types recorded in the study and available in the datasets. And yes, we would like to keep the quality of the data as a separate column. And we would like to include the accessibility score as well. Can we regenerate the current JSON file into the new format? Hey, can we update the HTML and the JavaScript code and the CSS as a separate files? Keeps messing up the folders. Yeah, it looks pretty good. Ah, wait. Where's the description? Can we bring the read more button for the description? You can just keep the following HTML and update the JavaScript and CSS to include to make sure the read more button is still there, but also have a read less button as well in the description column. my current JSON file, there is something wrong with how the first column is being fetched, the name and the year.
table looks good, but here are some suggestions for further improvement. 1. Reduce table width. Adjust the width of the table and columns to ensure it fits better within the screen. This can be done by tweaking the CSS. 2. Expand collapse description. Implement a more intuitive way to show the full description by using the Read More and Read Less buttons. Ensure these buttons work seamlessly. 3. Highlight quality and accessibility. Add visual indicators like color coding or icons for quality and accessibility to make the information stand out. Here's how you can update the CSS in JavaScript to reflect these changes. Updated CSS. Resources CSS style CSS. CSS body family Arial sans serif. Margin 0, padding 0, line height 1.6. H1, H2 text align center. Margin top 20px. Table container width 90%. Margin auto. Overflow X auto. Max height 80 VH. Overflow E auto. Datasets table width 100%. Margin 20.
Funny thing is that others are bound to make way more mistakes as opposed to. Where did you get the quality from? Okay, can you browse the next dataset in the list? Can you go for the next dataset link in our list? Okay, I'll share a JSON file with a list of datasets and some information about them in the next prompt. Now we want to go over every link. Perhaps do it one prompt at a time to confirm all the information in the JSON file is correct. That's a two-stage prompt. Okay, so it's verifying the first one as the link. I will now perform verification steps. Okay. Guess it's actually going to the dataset. And it didn't. Didn't actually change anything. Okay, can we move to the next one? Why don't we have the year? Hey, we do have the year for this one. Can you double check? No, check the link again. Actually browse to it. 2022, yeah, that's correct. Subject count is 50. That's right. It's actually downloading. Yes, you can go to the next data set. 2016. Yes, link is correct. (2020). Yeah, we already have the year. Those are mainly mod files. I can't access the page for whatever reason. Hey, can you try browsing to the link again? Here it is, just for your reference. Let's verify the results. Why the accessibility? Yes, you can download directly. So which one's Zenodo? I can download without login. Previous one. Same thing. Is this the one with the large EDF files? No, they're okay. They're like 50 megabytes or so. And you actually can download without login. Can download. This actually. Okay, which one's the next one? Yes, go to the next. Regulation of brain cognitive states. Why did you skip over this one? Alright, this one you can't do. Yes, we can confirm that, but pretty sure that one is correct. And that's the only one we actually know the quality for. Yeah, widely used doesn't mean the quality is good, does it? Yeah, we only essentially know the quality for the NeuroVista implant data. Yeah, anything else should be unknown, unfortunately. The unknown should be just yellow. No, yellow is not good. Yeah, we need to change the colors on the entire website. But yeah, we might never actually have time for it. Pa, 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 pa. So if you say search for seizures, yeah, it's then showing you 3 datasets that include seizure data. Otherwise, we have 9. Regulation of brain cognitive states. How do you know the quality is high? Mention of quality of life. Had 2 experiments. Hey, yeah, nothing interesting in there, especially because can't see any images. Why the EEG recording is so small? This one actually has a viewer. Yes, you can download it. It's the 4 channel. Might need more details on that one, but can download it without login. That's great. How do you know the quality is high?
The description on the PhysioNet page indicates that the dataset is well documented, includes synchronized timestamps and unified tags, and is designed for robust research applications. This attention to detail and the pre-processing of data suggests that the dataset is of high quality. For more information, you can review the details directly on the PhysioNet page.
If there are a lot of details to the dataset, doesn't mean that the data is of high quality, is it?
You are correct. The presence of detailed documentation does not necessarily guarantee high data quality. High quality data would also depend on factors like the accuracy of recordings, the absence of artifacts, consistent data collection methods, and validation against known standards. For a definitive assessment of quality, it would be necessary to review the data itself as well as any associated metadata and validation studies. The dataset description suggests robust documentation and preprocessing, which is a positive indicator, but it does not alone confirm high quality. Shall we proceed to verify the next dataset?
Is this going to be removed then, or what's up with this? The PhysioNet Challenger spent several days last month at Data Science Africa 2024. It was a hackathon over 4 days with more than 50 attendees, including some that we will win a prize. Yeah, you wish this was written with ChatGPT, then there would be no spelling mistakes. Is the data still... What is that? Ah, synthetic image that was generated from another ECG waveform, but it includes various distortions that resemble artifacts in paper ECG. Well, if this paper ECG was just like thrown out, well, synthetic image. What's generating these synthetic images? Is there an actual data to this, or... It's interesting because it's actually happening at the moment, but I'm actually, yeah, I'm not going to be attending any conferences or anything like that. But I would like the data. This one I'm mentioning, PhysioNet. It's a Nature article. Machine accessible metadata file describing the reported data. That's on Figshare. Yeah, that's on the like 3 kilobytes. There are several larger datasets that are either commercial or were access restricted by certain conditions. Okay, we like the non-restricted stuff. Available labels, average length, classes, patients, number of leads, number of ECGs. That's nice. Yeah, when we scroll down, can the titles of each column be still visible? Okay, this moody thing. Guess it's someone's name, is it? We might just pop the moody stuff. As like a special mention or something. Shall we move this link into a special mention or something, considering it's not a dataset? Did you actually browse to the link? Okay, now HTML. I have a research challenges section. And that moody business. I got to have the screen. PCI Challenge 2015. This one, 2014. Yeah, we actually know this one. 2016, that's okay. That will be just the EMG artifact, will grasp and lift. Should be EMG, not EEG. Now we have 8. And we can go to the next one. Yeah, the Kegel, they're really. I think on the website they have both competitions and data sets. Yeah, I'm thinking moving Kegel. Yeah, this is interesting because this is the same data set. This is the NeuroVista, but yeah, it's a mess. For memory, um, IEG.org had only like 5, only the dogs, not the human patients. Then the current one, the Pen something, Pen CF Discover, has only 3 dogs. And the original Kegel thing had 5 dogs and 2 patients. However, those are like snippets. They are not continuous data, which is okay for training supposedly, but yeah. Yeah, we have the solution of the. Yeah, this really should be in the competition section. Yeah, this is the same one, isn't it? Yeah, we might just leave it in there, the competition section. So again, remove it from here. Yeah, it didn't have any details. Can I only have 7? Yeah, let's move to the next one quickly. This will be the last. Suggesting more. Searching something. Suggesting a whole bunch. Don't trust it. Looks very old. Old, year 2008. Motor imagery. It's a competition as well, isn't it? The data sets are on the same side. So what's This does set 1 to A to B, 3 and 4. So essentially 5. There's no links or anything. It's a bit unusual. Yeah, it's a very old one as well. Should we let it go? Yeah, if I couldn't get the access to the actual data. What are GDF files? Yeah, that's the biosig. It's some sort of European. Yeah, it was last updated like 3 years ago, 2 years ago. Oh, yeah, okay. Well, yeah, I shouldn't say anything. 165 channels. That's interesting. The file is in XDF. built in C++. No, no, no. Okay, I think we can let it rest. The files even download. No, it's actually downloading. It's only 14 megabytes. It's actually downloading. Well, someone's still maintaining this page. Ah, okay, it's not much. It's even less. Yeah, MATLAB files. Ah, yeah, based on those images and stuff. Just added all these competitions, didn't? Those pages do work. Someone used it somewhere. Thinking fetching some more from somewhere. Just making them up, or are they legit? Not just repeating the same thing, is it? No, no, it's just hallucinating stuff. It can go really. I guess I should have the 7. Was 2002 to present. The present must be an elusive term. Ooh. There's a native CG folder. Is it meant to be shared? Uh, yeah, I'm not sure what that is. Some weird stuff. Oh, this website. Digital pathology, electroencephalography. It looks pretty outdated as well. Okay, show update. Actually, it's actually doing what you ask it to do, which is pretty amazing. You need to fill a form. No, we're not filling any forms. Pretty sure it's outdated anyway. Yeah, that's the kind of stuff. You must provide an email address that is registered with Google. What? What year? 2024. The Neural Engineering Data Consortium. It is updated, but it's ridiculous that they're asking you to have an email registered with Google. Electronic signatures. Like, no, no. Not happening. It's ridiculous. Why is it like a top secret data set? What? Once you have obtained username and password, you can selectively download portions of the copies using your browser. You can also use the resync interface described below. Do I have it by any chance? Why do I have a feeling some of it will be on Physionet? Can you find a link? Wait, it's one that we already have, do we? So the accessibility is not open access. What's selected? 18 is 17. Hey, where's the number of subjects from? Yeah, okay, this one. Temple University. So it's a different website, isn't it? No, it's the same. The university. Such a university. Let's just quickly include what we already had before. Or did I get rid of it? Yeah, there's a bunch of that's mostly human. One's already included, is it? Shouldn't have deleted that file. We can fetch it from here. all the stuff for the ads. This is the whole HTML. HTML old. Let's pop it in here. Don't need any of that. We have the platforms already. Get rid of this get rid of this table. Yeah, essentially to go through these links. Yeah, I have to. Yeah. Yeah, we can pop EG software into a separate. EG software in here. Devices. Okay, that can go. It says blogs. There's no blogs. Yeah, I have separate the page on software, SDK, APIs. Yeah, I might pop this into it as well. A non-detection. Yeah, publications we only do um, ones that have associated datasets to them. We have potentially publications with data. Maybe have to go over them. Hey, we get some more data sets. We pretty sure we covered this one already. Devices can go into a separate. Search for devices quickly. Yeah, we mentioned it in a bunch of places. Okay, we're left with datasets. Yeah, general health datasets. It's more like public health stuff. Yeah, we're still on the datasets. This one can go. It's general health data, so public health, which we're not really interested in. So we updated this table. It looks much better now. Currently only have 7 entries to it, but those have details to them. So like number of subjects, the types of patients, the formats of the files, what else? Yeah, general description and the link. And mainly we are after the quality, so we know that this data set, the quality of it is high. It does require registration though to get it. You can get it from other sources as well. It's in at least 2 other places. It's both on GitHub and IEG in that new University of Pennsylvania repository. Yeah, our ones. So we checked that you can actually download, start downloading the data without login in, was it 5 out of 7 cases, but the quality of the data is unknown. And what else? And we have a bunch of like loose other ones. Protection. Yeah, I try not doing anything on the cloud. I like doing stuff locally. You only need a sample of the data. Don't want to do unnecessary stuff. Yeah, Nature has data sets as well. Sometimes they will have this paper describing the data, which is great, but then the actual data is hard to. Single word production data set. What? Neurodata without borders. Neurodata without borders. It's a good name. It's a mediocre website, but the name is good. Yeah, that's the thing. If I'm on a data website and I can't get the data within like 2 minutes, what's that? Is it real or it's supposed to be spiking of neural activity or something? But it's like artistic representation. So in theory, meant to neurodata without borders. Okay, there's a newsletter. It's like I don't care about newsletter. Where's the data? I don't care about the team. Just show me the data. There's none. Publications. The data standard. Okay. Policies. Yeah, it's more of a regulatory thing, isn't it? Yeah, blah blah blah. Yeah, there's no data on this thing. Yeah, OSF does have data sets, single word production, Dutch. So yeah, would not be very interesting to me, wouldn't, because I don't speak the language. 5 gigabytes. You can supposedly. Yeah, normally from this website, yeah, you can go and download. Yeah, so what the button is hidden. But yeah, OSF is pretty good. It just goes and downloads. So it's a good data set. We do have it mentioned. Do we? No. Why not? OSF. What happened? OSF home. Search. Discipline. No. Wait. OSF, say EEG. Yeah, don't want projects, want data. Create a subject class. Well enough. What's special queuing task? I have no idea. How do you search this thing? Pre-prints, no. Meetings. Meetings? No. Meetings. Get started. Search and discover what? Learn more? No. Yeah, scary photo of someone. Get started. What? This the yeah, just yeah, would like Creative Commons. Blog events, board, blah blah blah. Center for Open Science. Yeah, Open Science is good. It's the data search. Well, maybe that's why I didn't include it. Yeah, the neuro data without borders. Well, I'll love to be proven otherwise, but it seems like it doesn't have any data on it. Same with like scientific data, nature thing. This journal. Got this journal, EG. It's all about search, isn't it? Normative longitudinal EG recording during sleep stage. This looks interesting. But that's not the article type. Research. Well, in theory, scientific data should have science should have. That's actually interesting as well, because we did some eye tracking on the website. Bum, 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 bum. Healthy, 165 participants. Technical validation. surely, surely this is not a figure from the article. This is meant to be what's it called, appendix or something. Yeah, I was actually looking for a 1010 better than what I currently have on the site, which the robot created for me. Obviously, this one is more accurate. What's CMS and here? What are the names? They're meant to have numbers. It's a weird one. Has task I've been executed. Has task I been executed 3 times. Okay. I could just say in a sentence, executing 3 times. Okay, eye tracking, text to speech, typing by gaze. That's nice. Yeah, probably should have an application like that on the site. How is it to do with EEG? And where is the data? Like a download. Download citation. No, I don't care about the citation. I don't need the PDF. Need the data. Quality control. Quality control. Okay, data records. What? The data set is available at where's the link? The data set is available at, okay, there's a link there to Figshare. Figshare has data sets. Oh, it's like endless. It's like yeah, data set. Spring in nature. What? Yeah, there it is. A data set consisting of EEG and eye tracking recordings obtained from 6 patients with amyotrophic lateral sclerosis, ALS, in a locked-in state, and 170 healthy. This is a very interesting thing. Download. Does download work? Yeah, download just works. Spring. And this is an interesting one. What are the files in? Oh, Creative Commons 0. That's a very nice license. It's essentially permitting you to do anything you like. It's like you found it on the street equivalent. You obviously acknowledge it's the the right thing to do, but you don't have to. There's no restrictions, which is nice. It's not super large, just 1.5 gigabytes. Eye tracking and EEG in a clinical population. So that's 170 healthy. Wait. In 6 patients with ALS and 170 healthy individuals. Okay, that's nice. It's very nice. BB determined PDF. What? Time scenario. So they all did 9 scenarios. Supposedly, yeah, EDF files are really nice. Yeah, this one goes to the list. It was just published just last month. Yeah, thank you very much. Thank you very much. Let's actually look at this one. I'll be wrapping up in a sec. But this is a very, very nice. What's the link? 35 downloads. Embed. Motor control. We might just download it now. Let's see what speed we can get up to. If the stream breaks, it breaks. It's okay. 9 hours, 6 hours, 5 hours, 3 hours, 2. 1 minutes. Okay, where's it downloading? It's just calculating, trying to calculate the time. Okay, it will take about 11-12 minutes, I take it, for 1.6 gigabytes. Okay. Maybe if I finish the stream, it will go faster. Spring image. We do have Figshare on the list, right? Hope so. Yeah, Figshare is first. And this particular dataset goes on the list, that's for sure. Let's just check, how do we... Yeah, that's the link. Let's just check that. Ooh. Ooh. Could not be found. What? Hey, why am I struggling with that? Okay, this must be... Yeah, it has this weird link. Hey, can you browse the following link? I think it should add it to my list. Visual fetching, issue fetching, why? They're not allowing it to crawl. It browse this. Searching the web. Yeah, got the details. So why? So what's the problem? Yeah, it's something with OpenAI that it can't browse. Is sometimes. Obviously, could do it over here. Okay, let's just say bye bye for now.
The Springer Nature Figshare collection, titled An EEG and Eye Tracking Dataset of ALS Patients and Healthy People During Eye Tracking Based Spelling System Usage, contains a valuable dataset obtained from 6 patients with amyotrophic lateral sclerosis, ALS, and 170 healthy individuals. This dataset includes electroencephalogram, EEG, and eye tracking recordings collected to study the use of an eye tracking based spelling system. The ALS patients involved exhibited varying degrees of disease progression, from partial mobility to complete paralysis and loss of speech. Data from ALS patients were recorded multiple times in their homes, while the data from healthy individuals were recorded once in a laboratory setting, across 9 different recording sessions for each participant,